Implicit derivation, slope of tangent line. Find all points on the curve x square y square plus xy equals to 2 where the slope of the tangent is minus 1. In these kinds of questions, we have to find dy by dx and then equate it to minus 1 to find the value of x and y. So let's start with the equation itself, which is x square y square plus xy equals to 2. Now let's take derivative on both sides with respect to x. So we get d dx of x square y square plus d dx of xy equals to d dx of 2. Now here we'll apply the product rule, and so we get 2x, that's the derivative of x square times y square, plus x square times derivative of y square, which is 2y dy dx. Now here is the product of x and y, so we get derivative of x is 1, so we get y here, plus x times derivative of y, which is x times dy dx, and on the right side it is 0 since the derivative of a constant is 0. So we can combine dy dx terms here and the other terms on the other side. So we get three terms, which is 2x y square plus y, and for dy dx we can say dy dx within brackets, this is 2y or 2x square y, and this one is plus x equals to 0. Now from here we can find what is dy dx. So dy dx for us is equal to this term, which is 2x y square plus y, and when we take it on the other side it becomes minus. So let me write minus here, divided by this term, which is coefficient of dy dx, 2x square y plus x. So that is the derivative for the given function at any point. Now we are trying to find where is the slope of the tangent minus 1. That means we should equate this to minus 1 and find our answer. So let's do that part. So basically what we are trying to do now is we want tangent to be minus 1. So we'll equate this to minus 1 and then calculate. So if we want to write this as minus 1, then we can cross multiply and we'll solve it on the right side. So we get minus and minus cancel. So basically it is 2xy square plus y equals to 2x square y plus x, correct? That is what we get. So we'll bring the terms together and then see how we can factor and then find the answer. So we get here 2x y square minus 2x square y plus we have y minus x equals to 0, right? Now what is common here? 2xy is common. So we'll say 2xy, and within brackets we're left with y minus x, and here we have y minus x equals to 0. So y minus x can be taken common, and we're left with 2xy plus 1 equals to 0. Now for this equation to be true, we have y equals to x as one solution, and the other solution is 2xy equals to minus 1, or we can write this as xy equals to minus half. So that is another solution for us. Now with this we can find all the points where the equation will give us slope of minus 1. So what we will do is, so if I write xy equals to minus half, we can, and x equals to y, so we can find out what is y equals to, right? So let me substitute either one of them. Basic condition is this. from the equation, right? So if I write y equals to x here, I get x squared equals to minus half, which is not a solution. So what we will do is, we will substitute x equals to y in the equation and solve for x. So if I do x equals to y in the equation, then what do I get? I get x squared instead of y, I'm writing x. Okay. So we get x to the power of 4 plus x squared equals to 2. Let me bring it on this side. Minus 2 equals to 0. Now this is a quadratic equation. So where we can factor it. It is minus 1 times minus. So we can factor this as x squared. So minus 2 is product of minus 2 times 1 and 1 times minus 1 times 2. So we can factor this as x plus 2 times x squared minus 1 equals to 0, right? So that gives us solution here as, so x squared plus 2 equals to 0 is not possible, but x squared minus 1 equals to 0 gives us two possible solutions. So that is x equals to plus minus 1. So that is how we can find 2 points which will give us a slope of tangent line as minus 1. So the point will be, when I plug in x as plus minus 1, what do I get for y? So we'll calculate the y point also. So if x is, let us say, plus or minus 1, then let me calculate first for 1 and then we will do for minus 1. So if I write x as plus 1, I get, let me use this space here. So I'm writing x plus 1 in our equation. So we get y squared plus y equals to 2, which is, I'll take 2 on this side, minus 2 equals to 0. And then I'll factor this. Same, it is very similar, right? So when I factor this, it gets y plus 2 times y minus 1 equals to 0. And that gives me 2 points. One is y equals to minus 2, the other one minus 2, and the other one is y equals to plus 1. And therefore, with x equals to plus 1, I get two different answers for y. Now let's also try this with x equals to minus 1. So when I plug in minus 1 here, I get equation as, let me write here. This one was for x equals to plus 1. Now we are doing x equals to minus 1. So if x is minus 1, minus 1 square is positive. So we get here y squared, but this becomes negative. So this is negative y. I'll bring 2 on this side, so I'll write minus 2 equals to 0. Now this will be factored as y minus 2 times y plus 1 equals to 0. Now here I get answer as y equals to plus 2 or y equals to minus 1. So these are the two different answers when x is equals to minus 1, right? So that is how we can actually solve the question. So the points for us are, so we can write down all the points as, let me push this page a bit and write down my answer. So the answer is, if x is 1, y could be minus 2. If x is 1, y could be 1. If x is minus 1, y could be 2. And if x is minus 1, y could be minus 1. So we have these 4 different answers, which are the points on the given curve where slope of the tangent line is going to be minus 1. So it's kind of a tricky question. Easier to find the derivative dy by dx, but to find the points where the tangent is minus is kind of tricky. So you need to do this factoring a couple of times and then get the answer just as we did it here. I hope that helps you a lot. Thank you.